hello. Okay, in the second part of 8.2, we are going to be doing the multiplying and dividing of rational expressions. And I know you've seen a lot of this before. This is just kind of, basically harder versions of what you've done previously. So, in our first example here for multiplying, there's different methods of doing this, okay? So if you like doing it a different method than the way I'm going to show, that probably is going to be okay. I guess bigger picture here. One method is to simplify each fraction individually first. So this fraction on the left-hand side, you could reduce these x's down, and then that would be it. And then you could go to the second fraction, and you could reduce the x's down, and then that's it. And then you could multiply the two fractions together, and then simplify that. So that is one correct way to do it. It's just, to be honest, there's not like a great way that works every time. Another method is you could multiply everything on the top together. So you could get 30, I'll erase this in a second. You could get 30x to the 6th, y to the 5th, and then on the bottom you would multiply the whole bottom together, and then you would get 24x to the 5th, y squared, and then you would take this answer and reduce that down. So that's the other main method. And then you can kind of do a combination of the two. So what I like to do is I like to think of, when you're multiplying fractions together, I like to think of this as essentially one big fraction bar. And so my top is made up of 2 times x to the 4th times y to the 5th times 15 times x squared over 3 times x squared times 8 times x cubed times y squared. And the reason I like to think of it like that is because I like to simplify all that I can before I combine everything. Let me get rid of this. I know I'm kind of weird about this. Let me get rid of the dots to make it less messy. So I'm going to simplify any multiplier from the top with any multiplier on the bottom. And I guess I'll just start with regular numbers. So I'm going to say the 2 on the top is compatible with the 8 on the bottom. So I'm going to reduce both of these down. And you know what? Actually, I'm going to pick a different color. Red's kind of hard to see there. So I'm going to reduce the 2 and the 8. And so if I divide both of those by 2, I'd be left with 1 and 4. And then I've got the two other numbers. I've got a 3 and a 15. So I'm going to divide both of those by 3. Oops. And so then this would become a 1 and this would become a 5. And then I've got a whole bunch of letters, but I've actually only got 2 different kinds of letters. So this somewhat depends on you trying to keep your work neat, because it can get confusing, lost, whatever you want to say. So I'll actually start with the y's, because I've only got 2 of them. I got y to the 5th on top, and I've got a y squared on the bottom over here. And in my head, I think about it as I've got 5 on the top, 2 on the bottom, and so I could take 2 away from both of them, and that would leave me with 3 y's on the top. And then I'm looking at the x's, and there's different ways to combine everything together. So I've got x to the 4th on the top, and then I've got x squared on the bottom. So I'm going to put those two together, and I'm going to cancel 2 of them from bottom and top, and leave me with 2. And then over on the right hand side here, I've got more x's. I've got 2 on the top, 3 on the bottom. So what I'm going to do is I'm going to remove 2 x's from both of those, and then that would leave me with 1 x on the bottom. And before this gets ungodly messy and complicated, I'm going to kind of rewrite it and simplify it together. So I've got a 1 times an x squared times a y cubed times a 5 times 1, because this x squared that was canceled out is a 1. And it doesn't matter if you write 1 or not, but I want to clarify that. On the bottom, I've got a 1 times this x squared that was reduced is a 1 as well, times a 4 times x to the first times, and then this y squared that was canceled is a 1, so times 1. And if I try to simplify this, I have 1 times 5 times 1, x squared, y cubed. On the bottom, I've got 1 times 1 times 4 times 1, and then I've got x to the first. And then I can actually simplify that down a little bit, where the x squared on the top and the x on the bottom can reduce. I can remove 1 away from each one of those. And then that would leave me with, I can write this a couple ways, 5x to the first y cubed over 4. Or some people like to write the number kind of as a separate multiplier. So you could write 5/4 and then x y cubed. Both of these would be considered correct simplified answers. Now, in the last video, we talked a lot about which numbers couldn't be used in place of the variables, and then that's technically true here too, but you're probably not going to have to answer that kind of information when there's more than one variable. Not that it's incorrect or different, it's just you're generally not going to be asked about it when there's more than one variable. So that's why I didn't write anything down for this particular problem. Okay, and again, there's multiple ways to do this. You kind of pick whatever seems easiest to you. So I've got a problem for you guys to try next. So why don't you pause it on this one and then see if you can simplify it down. And if you simplified it down, this is what you should have gotten. Now for this particular problem, just because it seemed like things were seemed simpler to me, what I did was I multiplied the entire top to get 20x8. I multiplied the entire bottom to get 30x5. There's no reason you couldn't have done like I did on the last problem where you cancel beforehand. It's just kind of total personal preference. So the 20 and the 30, the 20 and the 30, I canceled that, divided both of them by 10. And then on the x to the 8th and the x to the 5th, I took out 5 x's, so basically divided by x to the 5th, and that left me with 3 of them on the top. And so then this was my simplified answer. Now, if you wanted to, you could absolutely say x cannot equal 0. If you want to get in the habit of like from when we were doing it yesterday, but on this particular one, you didn't need to. All right, let's move on. Okay, second example. The reason it is considered different than the first one is because you have more than one term. So on the first example, everything was monomials. There were no plus or minus signs anywhere. On this one, these aren't monomials. And so for you to be able to cancel, you actually have to be able to rewrite everything as multiplication to be able to cancel. So like this x plus 2 that's on the top of my fraction, I'm going to kind of treat that as x plus 2 in parentheses. This x plus 4, I'm going to kind of treat it together because the only way I can cancel is if I have an entire x plus 2 multiplied on the bottom. And if I'm looking on the bottom, it looks like I can actually factor these two different things. So this first one on the left, the first denominator on the left, I can take a 3 out of both of those. And if I divided 3 out, it would leave me with x plus 4. X squared minus 4 is a difference of squares, and that could factor into x plus 2, x minus 2. And then if you want to rewrite it to make it simpler, you certainly can. It's just kind of your own personal choice. You can rewrite this as x plus 2 over 3 times x plus 4 times x plus 4 over x plus 2, x minus 2. Now, I'm multiplying two different rational expressions. So what I do in my head is I consider it one big fraction. because that's what multiplication does anyway. You multiply the tops, you multiply the bottoms. And when I do it like that, then it's much easier to kind of think about canceling, for me anyway. So this x plus 2 that is multiplied on the top, I can cancel it with an x plus 2 that is multiplied on the bottom. And an x plus 4 on the bottom can cancel with the x plus 4 being multiplied on top. Now, the canceling and reducing, I should be better about this. When I divide x plus 2, it would actually leave a 1 in both spots. When I divide x plus 4, it would leave a 1 in both spots. And the main reason that's kind of important is to help keep straight what information is left. Like my numerator is technically 1 times 1. My denominator is technically 3 times 1 times 1 times x minus 2. So it would be 3 times x minus 2. If you would like, you absolutely could multiply that 3 out. You don't need to. It's just different ways of writing the same answer. Now, again, you're not being asked about which values couldn't be used, so domain restrictions. But if you were, you would go to the original problem and you would take each factor and set it equal to 0. But when you set 3 equal to 0, that doesn't give you any answers. But each of these other 3 factors, when you set them equal to 0, would give you 3 different domain restrictions. So I'm mainly kind of doing this so you get used to that habit or that practice. But the domain restrictions, if you were asked for them, would be -4, -2, and 2. Okay, good. I'll let you try an example for multiplying factors. So, pause the video. Try to simplify this down. Now, if you factored it correctly, this is what you should have gotten. Almost everything cancels out except for a 2 on the top and an x minus 2 on the bottom. And then that would be your reduced answer. If you were writing domain restrictions, then what we would say is x cannot be 4, 2, and -3. I'm looking at the factors of the denominator. Okay, so that's it for multiplying. Let's move on to division, which actually isn't a ton harder, but still is slightly different enough that I know you might need to see some examples of it. Okay, and you might even remember this one step. Basically, the rule is that you can't divide fractions. So what you have to do is you change it to multiplication. And I believe this is what some of the junior highs refer to as KFC, isn't it? I believe it's like keep the first, flip the second somehow. But what you're going to do is, instead of division, your first fraction stays identical. Your second fraction flips upside down. And then you'll notice I changed it to multiplication. That is literally the only one thing you have to do. Everything else from here on out is exactly what we just did with the first 2 examples, because now this is multiplying fractions. And what I'm going to do is I'm going to cancel and reduce things. I'm going to treat it as one big fraction. And I'm going to cancel any multiplier from top to any multiplier on bottom. I've got a 9 that reduces out. I've got a single y on the bottom that can cancel one of the y's on top. I've got a 4 and a 16, so I'm going to divide each of those by 4. And let me put 1s in place of those 9s. And then the x's, it looks like I got 3 x's on top, 2 on the bottom. So I'm going to cancel 2 of the x's and leave 1 on top. And if I do that, my numerator has 1 times x to the first. And if you can do this in your head, go for it. I'm just trying to write it out to be somewhat clearer here. So 1 times x to the first times 1 times y to the fourth. And my denominator would be 1 times times 1 times 4. So I am left with x y to the 4th over 4. Or, again, some people like to write the multiplier separate. You would actually write this as 1 over 4, because the 4 is on the bottom, x y to the 4th. That would be your simplified answer. Okay, here's division with factors, but exact same first step no matter what. With division, that's pretty much the one thing to remember, is I'm going to keep the first fraction identical and change it to multiplication, flip the second one upside down. Okay, now factoring, it looks like we definitely have a lot of factoring to do on this one. So I'm going to do factoring first. So x to the 5th minus 4x cubed, they both have x cubed in common. So I'm going to factor out x cubed. And then that would leave me with x squared, 2 of them left, minus 4. And then actually x squared minus 4 can be factored more because that's a difference of squares. That can be written as x plus 2, x minus 2. My denominator, I have x squared minus x minus 2. That can be factored as x minus 2x plus 1. Because then these would multiply to negative 2, add to negative 1. X squared minus 1 factors into x plus 1, x minus 1, because that's a difference of squares. This denominator over here, they all have an x cubed in common, kind of like that first one up on top. So I'm going to take the x cubed out first. That leaves me with x squared minus x to the 1st minus just a 2. And then x squared minus x minus 2 factors more. That factors into x minus 2 x plus 1. Okay. And you know what? Instead of me, I'm going to rewrite this because that's just a lot of stuff. So I'm going to rewrite this to somewhat keep it simpler for me. X cubed times x plus 2 times x minus 2. And I'm actually going to put both fractions together. X plus 1, x minus 1. And that is a huge top of the fraction, the bottom of the fraction. X minus 2, x plus 1, x cubed, x minus 2, x plus 1. And then I'm going to go look to see what factors they have in common from top and bottom. So I see an x cubed right away. So that can divide or cancel out on both of them. I do not have an x plus 2 on the bottom, but I do have an x minus 2. And I could have canceled it from either spot. I do have an x plus 1. So then that would cancel over, honestly pick either one of them, it wouldn't matter. And then I believe that is it. So it looks like a bunch of them canceled, but then some remained. And whatever is remaining is kind of your simplified answer. So I've got an x plus 2 on top, I've got an x minus 1 on top. On the denominator, I've got an x minus 2 and an x plus 1. Now, if you felt like you wanted to multiply it out, you could. You don't need to. But if you did multiply it out, you'd get x squared plus x minus 2 over x squared minus x minus 2. And this would be kind of your simplified reduced answer. All right, excellent. Let me put one up for you guys to try. I put one of each style for you guys to try. Why don't you pause it right here? Oh, I did not put one of each style. I put one of the harder ones. But here is the answer to that one. You'll notice off on the side, I tried to do all the factoring over here so that it wasn't quite as messy. And I'm hoping that helped. Basically, this is over here. This is right here. This is right here. And this is down here. So if you need help matching up where they go, that's it. Okay. Nice job. That is it for this section.